Over the past week or so, I've been seeing a lot of variations of this post, which asks the viewer, why do Germany's 3 biggest cities lie on a circle? And sure enough they do. Berlin, Hamburg, and Munich all fall neatly on this circle. And so does Luxembourg, but that's not really relevant right now. So if you're like me, you might think, that's a strange coincidence. But then you remember you're on a subreddit about map memes, so there must be a trick at work here. Obviously the trick is mathematics. It turns out that you can draw a circle that includes any 3 points, so it wouldn't matter where the cities are, they will always lie on a circle no matter what. That is all well and good, but I'm sure you are dying to know how you can draw circles around 3 arbitrary points. Think of all the fun you could have by showing these meaningless maps to conspiracy theorists and getting them all worked up about nothing. Before we start drawing things, let's precisely define what a circle is beyond just a thing that's round. Google defines it as a round plane figure whose boundary, called the circumference, consists of points equidistant from a fixed point, called the center. So if we want our cities to fall on the boundary of a circle, we need to find a center point that is an equal distance from all 3 cities. With that out of the way, let's start by positioning and labeling our 3 cities, which we'll just call A, B, and C. Next, we'll draw a straight line from A to B, followed by another one from B to C. This is where things start to get interesting. We're now going to cut the line from A to B in half with a new line that passes through it at a right angle. This is what's called a perpendicular bisector. It's a line which splits the plane into 2 halves, one containing the points closer to A and the other containing the points closer to B. We can conclude from this that points falling precisely on the line must be an equal distance from A and B. Now we'll add another perpendicular bisector between B and C. Consider what we know about the point where the 2 bisectors intersect, which we'll call P. Since P falls on the bisector between A and B, P must be an equal distance from A and B. At the same time, P also falls on the bisector between B and C, so P must also be an equal distance from B and C. We can combine these 2 equations or pieces of knowledge to tell us that P is an equal distance from all 3 points, A, B, and C. This is precisely what we needed to construct our circle, a fixed center point at an equal distance from the 3 cities. So let's draw a circle centered at P, whose radius extends out to cover the cities. There is one situation where this procedure we've just followed will be unable to produce a circle, which occurs when all 3 cities fall perfectly on a straight line. We would call these points collinear. This breaks the procedure because our 2 perpendicular bisectors will be parallel to each other, and as we all know, parallel lines never meet. However, in the real world, this shouldn't happen because any seemingly straight line is probably a little bit wonky when you zoom in far enough. So you would probably just end up with a really distant point of intersection and therefore really huge circle.